It's like 2:06 a.m. Anyway, so today we are. Ugh, this is the Vornado. I think it's a 660 or something. Um, it is a quite a good fan. Like actually have a fan going on there, but like it's loud. This isn't loud. This also pushes a lot of air really well. So today, what I want to do is to make it work on Wi-Fi because let's just plug it in. So when you turn it on, it goes on full blast. I'm gonna do that. It's like kind of loud. What I might do is turn off my noise suppression. Click there, and click that. So this is no noise suppression, and turning it on. So as soon as you turn it on, it goes to full blast. It's kind of loud. Level 3. Level 2. And finally level 1. So this is okay. Like it's gonna be on the floor anyway, so it's not too bad. But yeah, this pushes quite a bit of air. It's quite nice. And off. But you see how I had on level 1 when I turned it off? When I press it, it goes back to level 4. That's annoying. So what I want to do is, firstly, is to make it not do that, but also I want to connect it to Wi-Fi so I can control it through my phone. So yeah, in order to do that, we're gonna have to open it up and figure out what the pinouts are. So I'm gonna turn back on my noise suppression, and through the magic of $50 camera, we have another thing. I don't know if it's in. Oh yeah, it's pretty accurate. Not accurate. Aligned, synchronized, whatever you want to call it. Okay, so unplugged. Yes, it is. What we're going to do is void our warranty and open this up. When I figure out how. Okay, so there's a screw there. What looks like these screws. So I need to open up pretty much this here. This might just be the. I don't know if it's going to help. Yeah, that's not really gonna do much. We'll tighten that later. How do I open this? I don't want to really open the front, but I think I have to. So if that's the case. Okay, first let's just tighten this again. Actually, let's untighten it. Take it out. It's not really popping off, even though I'm turning it. Alright, I'll just tighten it, whatever. I'm not sure what it does. But yeah, it's attached. Maybe like we rotate it all the way to it off. Anyway, so I'm gonna take out this screw. My magnetic pad is here. Ba, ba, ba. Here. There seems to be another screw at the bottom down here, but we can leave that. I think that's just to leave it onto the bottom base, but I don't need to touch that really, so that's fine. That was one more here as well. So I think I can pick this up. Oh. Right, so let's not touch the blade. It's basically just a fan, but yeah. So here is the grill. Pretty simple, and got a triple blade, which is a little scooping. I guess that's how it works. We have a 450 VAC. Decent spinny boy. Okay. Our controller is here, so I don't need to touch the motor stuff. I just care about our button panel, which is here. Oops. Maybe I'll leave that screwed. Okay. Just those two, or is more? There's small here as well. No, okay. Jewel's a bit too big. Get a smaller jewel. That would help. For now, let's do. My other screwdriver is. Oh, let's just put away right now. Okay, small one. There's another small one here. Thank goodness for magnetic screwdrivers. Oh, okay. Next up, we will play some music because it is quiet. Ba 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 ba. And I'll change my background music to play some music. I'm gonna put that down low because this microphone, I believe, is not very loud. Alright, cool. So, moving on. Oh, let's not get stuck. This opens up somehow. Maybe the back lifts up. And the front lifts up? Oh, there's another screw. There's another screw. Okay, I'm gonna switch screwdrivers to smaller sets. That should be better for the camera. I have no idea. Probably not because my hand's in the way anyway. Cool, okay. There we go. Now this thing probably also comes out. Let's have a look for any more screws. I don't see any. Maybe one hidden. Possibly one there. But I don't know how related that is. What is this here? 275 volts capacitor. Feels like I think they're just stuck in by brush. Yep. Okay, I can wiggle it out a bit, and then I think we will unscrew that. Rotate, rotate, rotate. It's spinning, but it's not really unscrewing. Never mind, jokes. I'm just weak. Okay, what did that even take out? Protective clip? Oh yeah, it's a clip. Somehow. I'll take the fan blades out, that might help. Yeah. Right. I think that was a cable restraint. What seems to be a cable restraint. Pull that, pull up. So I've got the triad, it's not a triad, well, we've got that thing there in the way. We've got two, so one of them is power in, the other one is our control signal. Alright, let's have a look at the control board. This guy here. There's quite a bit of space that I can actually put like a controller board or something. For example, I can put it like anywhere along inside of here. That just sits into all of these space. So I have quite a bit of space. Okay, so is it visible? Not really. Let's bring you closer to the camera. Good enough. Okay, so you can push the button. It pushes these buttons here, and so I just need to map these ones out. There is a, what is it? There's our beeper, a few resistors for what? Our mains. That's connected to these transistors. And then they pass around between the boards. Yeah, so. Want to listen? Whoops, I dropped the button. different signals. Push the button back in first. Okay. And got a part here. I'll just take a photo of it. Cool. So it is a 1F brightness, camera, focus, lack of focus, sadness. Let's try to focus that. This one? No, that's the aperture. Oh, yeah, okay, that kind of helps. There, so it's a 11 FXF J something. Let's see what that is on Google. Okay. Whoop. So 11 FXF J0132. 11 FXF J0132. Nothing. Okay. Chip. FB2521M. I see. Chip. Right, no idea what it is. Okay. Whatever then. I don't know what this is for. This middle one. Just the buttons, just a button board. Kind of interesting how they did that. Why is there a... Okay. So it was. So it's just to fit that one single button. Okay. Oops. This is not the best screwdriver. Magnetic screwdrivers are nice. Okay, so let's put this back. Push the buttons to make them press. Cool. And let's look at the bigger one. Push these cables up first. Okay, so those three are out. We have a, what's that? Brown, black, 1 to 120,000, maybe? Okay, how do I lift this one up? Got a few things here. Okay. Rotate it around. So here we have another 11 FXF. Wait, jokes. This one here. That dude. That looks to me something like a fuse. Um, 250 MXF 330O. I have no idea what these are for. Oh, my buttons are falling off. Awkward. Neutral component AC. Got 5 volts, ground, and 170. Okay, so okay. So that chip, it's a chip here, the one I saw before. Looks like an MCU. I'll just peel off the label. Nope, that didn't work. Useless tools. Okay, we've got some text on the device. Let me get some alcohol. Just give it a wipe. Let's have a look. Okay, I'll take one without flash as well. I think it is legible. It's a bit hard to get the angle. There we go. And we'll do a flash one from that same perspective. Oh, okay, I lost that. Okay, so it is a Sonics SN Sonics SN8P2501PBP 8-bit microcontroller. Is a risk like low power consumption, one clock instruction, or up to interrupt sources, stuff like that. Programmer. Okay, well, I'm not going to like write a chip anyway. I just want to see what it is. Okay, so that's a microcontroller. Basically, that's all right. So I guess what I want to do is to figure out where the buttons are. That shouldn't be too hard because we already know that. Switch back. We already know that the buttons are just at the bottom, so they just correspond to the pads. I just need to make sure that I have the right buttons to the right. Where am I? That's it. You know what? We'll do that later. Okay, I'm gonna. Can I take this out? I'll take this out. Do I want to take this out? It's gonna be oily. Not really. Do I have a spanner? Nope. But I do have a pair of pliers. Not the best. These are for electronics, not lug nuts. And also, I was going the wrong way. There's a bit of Loctite. By a bit, I mean, there is Loctite. Can I pull you out? No? Okay. I will put you back then. Give you a good tighten. Okay, good enough. So 5 buttons, 1, 2, 3, 4, 5 will effectively be that's my is it visible? Yeah, it's very tiny. Let's zoom in maybe. But with the power of zoom, this way. Wow, that is out of focus. And I need to bring you closer. I need to bring you closer. Bam. Yes. Oh, it's actually not bad. Let me put my screen so I can also see it maybe. Window projector. Yeah. So let's focus. That's aperture. There we go. Nice and decently sharp. Okay, so buttons is, what am I doing? When we press buttons here, so there's a button between these two contacts, a button between these two contacts. So what I can assume is, since we press this here, this is going to be our ground. This second trace here, this one is ground. And that's inferencing because this is also connected to this. So this is our signal. And so I need to attach something there later. And something to attach onto there as well. So this is signal, this is signal. And I think we can... Oh wait, 1, 2, 3, 4. What are these two? What is this? It's a negative. And then this here is some other stuff that I don't care about. Okay. We go on to the other one as well. Let's do our continuity. That's my multimeter. Okay. Just chuck you there. No, okay. I'll put you in camera shot. Where's the camera? Camera's visible here. Ah yes. Very nice and in the way of everything. Okay, so assuming this is ground, I am not on the right modem. No, I am. This would be 1 pin. Okay, so our ground or supply, whatever it is this long patch, this one here, as well as this trace here, which I'm not sure if you can see. No, you can't. Rotate! So, this one as well as this one. Yeah, okay, so that's not too bad. What about our supply voltage? Our supply voltage was... Let's take off the other screw as well. I don't know why I put it back. That's all of them. And get rid of this. Okay, it's much easier to look at the components. That's the board. Let's take a photo of that as well. Single button board. Don't know why I'm taking a photo of it. Let's turn off flash and do the same thing again. And both together. Also take a photo of the rear traces. Might use flash for that one. No, bad idea. Yep, no, okay, without flash is a bad idea. Alright, okay. So, what do we want to do with it? We will attach a jumper wire to the perspective. Yeah, so here, this is our ground. Let's put this up here. So ground is here. Top. It's not very... Okay, it's just my left probe, that's fine. And then this one here and this one here. So 1, 2, 3, 4, 5. We want to find our voltage plus, which is... Where's our voltage regulator? Power comes in through this top here, goes through a thing there, got our rectifiers are here, fat ceramic capacitor resistor. Okay, I see 5 volts. I think it's that line there, and that goes over to the rest of the board. So this one here is the power board, and this one here is actual logic. Maybe I can just solder it. Yeah, I might just solder everything onto here. Makes it easier to yoink later. In that case, let's do the pinouts. Dot is on bottom here, so this pin 1 up here. You know what? Let's just look at the pinout of the board. What was it called? Google. I see. Give me pinout, give me pinout, give me pinout, give me pinout, pin. How many? What's the package? 1, 2, 3, 4. 14? 14. Pin 4. Pin 4 is our VDD. So if that's the case, then pin 4 is this one here, which should connect to one of these. I did not get a touch. 1, 2, 3, 4. Okay. This pin here, same as this pin here, same as this pin here, same as this pin here, up the resistor, okay. And that is connected to our, okay. Oh, there goes my multimeter. That one is connected to a bat cable coming in from neutral. What? That one. Okay, so pin 4 is our power. Let's find our ground. What ground? Ground says it is. I don't see ground. Do you see ground? So VDD, that's power in. What about the rest of it? Reset X out. What's X out? Interrupt. Let's just take a screenshot of that. And we'll just double check our pin count as well, before I screw up or anything. 1, 2, 3. Wait, we'll cut for the top. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 14. Okay, so let's have a look at our thing. Power, supply for digital circuits, input Schmidt trigger, disable for perspective, by output, buzzer, pull up resistor, P10 open drain, X out oscillator, X1.2. VSS, I think. Alright, I assume VSS is our eventual ground. You can see that there's a gap between our X in, but there's a VSS out goes to ground. Let's just double check that. So our VSS was 11, which is 4, but on the other side. So if we have a look at that, let's just hook up this to a known ground, such as this dude here. Let's just double check. Yep. Cool, and we put it to 4. I'm not getting a signal. 1, 2, 3, 4. You know what I am getting it from? Pin 8. 1, 2, 7, 3, 4, 5, 6. Wait, what? When you press my button's here. So the button's here. We are bridging some traces to run into 3. Pretty sure this is supply. 4. Our button grounds. That's. Oh yeah, no, that's right. That's this first one here is a. It's not visible. Dope. That's a resistor. That's 1, 2, 3, 4. So this is our power, and then this one here should be ground. We can double check that. Let's be dangerous and plug it in, I guess. Yeah, what could go wrong? This could start spinning and we'll feel sad. What could go wrong? Let's plug it in. Yeah. Okay, not dead yet. It's a good start. Let's just measure some voltage between our bottom and top. Let's put it here between this one and that. Oops. Wait, 4. 1, 2. 1, 2, 3. 4. Okay, 5 volts. That is our 5 volts. Unplug. I don't know how much current there is though. But we can try and connect like an Arduino or something to it after. But for now, it's unplugged. Yes, it is. Let's find out where all of the contacts go. So the first one is our... What's our first thing? First thing is a power. Power 4321. That's power. Great. I didn't see any. Why am I not seeing anything? It goes onto the board. No. Yep. Where's my trace? Where's my beeps? Beeps. Beeps. Where are you? Well, that was unfortunate. Let's try this one here. One, 2, 3, 4, 5, 6, 7, 6, 5, 4, 3, 2, 1. 8, 9, 10. Where's ground? One, 2, 3, ground. That's my ground circuit. This is my contact circuits. Why are they not touching? That's connected there. Why are there 3.3 things everywhere? Okay, well basically it will be that pin there. Okay, so pin 3 is now what? Pin 3 is level 1. Let's write it down. Pin 3, level 1. Okay, let's look at the next one. So now our level 2 pin is this pad. So we want to look at this button. Travels to this pin here. Pin 5 goes to level 2. Let's go for the middle one. What? Okay, these do not conduct. Yeah, I'm making a jumper. Okay. Oh, wait, no, that goes to here. Huh. That was awful. Okay, so that second pin, so I'm going to trace it to grip. It's a bit of a tight one there. Kind of not really clipping onto anything, I guess. No worries if you can't. Whatever. Second pin. One, two, three, 4, 5, 6. 6 is for our middle one, which is level 3. Pin 6. It's actually not 3, is it? It's 14, 13, 12. Oops. 14, 13, 12, 11, 10, 9. Okay, let's look at the next button, which is our level 4 switch. Here. Okay, and so here goes to our bottom one here. To confirm, this is ground. Yep, okay, so that last one presumably jumps over to here, given the resistor. So here we'll link to uh, 14, 13, 12, 11, 10, 9, 8. Pin 8 for level 4. And then finally we have our power controller, which is the last button here. And that is this one here, which is the third one. Third one connects to here, which is gonna be probably, let's guess, this, nope, this, nope. My guessing sucks. One, two, three. Oops, sorry. Pin 3. Pin 3 for power. Okay, so that's what we have right now. So we've got this dude has the, basically let's just flip it around and we will flip horizontal and rotate it. This is what we're working with when we're looking at our circuits cross. So like that way you can go left to right, That's the same as our left to right here. So what I'm going to do is I'm going to click here, and drag my OBS on top. And let's just fix that cross. Might take a screenshot, maybe. Of that. Or screenshot, wait. Okay, screenshot that, and we can label it. Let's just save that somewhere. Desktop. Great spot to put everything important. Just like that. Okay, we'll make another image. And we will label some stuff. Maybe in draw.io actually, since things won't break when we copy and paste. Image too big. Screw you. Resize. What do you mean, image too big? CB 85422. There we go. So this is pin. Yeah. Nope, undo. What color? Let's go. This. Give it a nice Comic Sans. I'm kidding. I'm actually not kidding. Banana. Okay. This is pin 1. Maybe a bit of a background. Maybe a shadow. Can I do shadows in here? I don't think I can. Bold. Maybe with enough. Oops. 2. Oh gosh. 3. 4. 6. 7. 8. 9. 10. 11. 12. Actually, these should all be inside. Should be obvious enough that there's a difference. Okay, so pin 3. Oh yeah. So that's power button, not the power itself. like that. 4 is actual VCC or VDD, up to you. What do you want to call it? Eight, 9, 10, 12. 8, 9, 10, 12. Okay, so 8 is level 4. 9 is level 3. 10 is level 2. 12 is level 1. Like that. And we also know that 11 is our ground. Or whatever you want to call it. Okay, that is not legible, so let's give these guys shadow. Ew. Good enough. Okay, so we need to plug in those pins, and also we want to kind of also connect it to the inputs of our Arduino so we can read in the states. I wonder if there's a way to. To know which, if it is on or not. There's probably a sensing pin somewhere. Or just a way to figure out like what mode, or maybe it's just like it's active select. I'm not too sure. So what we can do is to figure out do I have ground on this? No, we have no ground. Earth, I mean. So we've got 4 cables going into our motor. We've got LL, H, M, oh wait, HMLLL. I reckon those HM things are just 4 separate signals. So they all share the same power bus, which is this, what? 5 volts? 5 volt ground. something. Oh no, that's not. It's wow, that's very closely put next to each other. Okay, so AC is here. It's 4919 1A60 1A60 4919. Four nine one nine 4919 1A60 1A60 2N. That wasn't useful. No. PNP. PNP means that this into there, into there. Or whichever way, really. And they're controlled by these guys. This is a 120 volt line. That's not a 120 volt line. Is that a 120 volt line? That's not a 120 volt line. That's a 120 volt line. 230 volt line. Not bad. Okay, sure. This is live supply, neutral. And that goes into all of these 1, 2, 3, 4 circuits. Those connect to their respective motors, which powers things. I could do something very dangerous, press that and then measure between there and there, but I don't really want to do it when that motor's spinning. Yeah, let's not do that. What controls them is this 1, 2, 3, 4. That's pin 1, pin. What's that? Is that a link? Resistor. What about between here and here? There's another resistor. These are the same resistors. Brown. Yep, they're the same resistor. Same 4 set of resistors. Possibly it's, I don't know what that one is just doing. It's just bridging those two. No, it's not. Oh, okay, so this connects to there, which connects to there, which connects to there, there. Okay, so that's telling us that pin 1 is for powering LL. Oops, I wasn't showing that. My bad. That's right. So that's LL sensing. Let's just switch over to the other one. Yeah, so I just figured out that basically this blue wire here is a neutral from AC, and that goes into here, which powers transistor, which is these guys here. And then they go on to these 4 HM, oops, out of mind, HMLLL. And then this is pin 1, which goes over resistor, which goes to here, to there. So we want to follow the same thing. This one has a trace. It actually goes there. That's pin 3. Pin 3 is power. Pin. That's not 3. That's 14, 13, 12. But 12 is level 1. 14, 13, 12. That's not good. That is 12. This is 1. 1 goes to low. This dude. Eight, 9, 10, 11, 12. Yep, it's definitely matching on 12. What about the other ones? Yeah. That's 13. 13 is for medium. Pin 13 is for medium. Pin 1 was for LO. What about high? Pin 12 as well? Oh, that's 14. 14 is high. Oops, 14 is high. High, medium. I want to figure out where low is. Fourteen, 13, 12, and I have 12 already for level 1, so let's find the level 1 button, which is the last one on the panel. So let's go this way. Level 1 is this button here. This is our ground. Oh, that's pin 2, isn't it? One, 2 is our input button. Ground, power. That's 2. 2 is our input. Pin 2 is our level 1 button. Whilst pin 12 is our low power. Okay, so yeah, level 1. Let's update that diagram. 2 is level 1. This is pin 1 is LL power. That's why we have a shadow. Okay. Next is our 14, 13, 12. I is 14, 13, 12. And let's move that up a bit. Can move that up a bit. Can move that up a bit. And okay. 7, 6, and 5. 4 and 6 look bridged. 5. Five's doing something with those two. One, 2, 3, 4, 5. Gonna follow this quickly. Probably a bugger, maybe. I don't know. I just think it. I think it's the other circuit model. So 5, 6 of this is actually not good now. I'll do that open and shoot. What's the next? Actually, it's out really good assets. Really well connected to it. Yep. 1, 2, 3, 4, 5, 6, 7. 7 is bridged with this, which is connected to 4. So that reset is held. VPP is held high. Exactly. Okay, so this board operates pretty much at 5 volts. We can save this as a PNG. Untitled diagram for the win. Let's just have a look at that. 1.02 megabytes. Oops, I pressed something, but yeah, there we go. Inits HD quality. So what we need to do is solder quite a few pins. Oh my goodness. Or if I forego trying to listen to what the user puts in, we can save some pins. Otherwise, hopefully I can just read in these pins. Alternatively, oh no, like, so if I'm to send a power signal, I effectively need to pulse power and then immediately set one of these things here. Now, if I press one of those manually, if I press one of these buttons manually, then I could technically listen to it. Now, I also want to be able to listen to these signals, because if these signals are pressed, then we know that it's on a certain thing. But if they're all empty, then we know that it's off. So I could do a poll and just say every 50 milliseconds, see if any of these ones are on. Yeah, okay, let's try that. How many ports do I need? 1, 2, 3, 4, 5, wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Arduino. With Wi-Fi or Bluetooth? Just Wi-Fi, I guess. Do I have any ESPs? Speaking of which, I broke this ESP somehow. I don't know how I broke it, but it's... And this is the one which the micro USB doesn't power. Yeah, I think I burnt out the power regulator or something. Can't smell it anymore. Where am I? Okay. USBs. Oh my god. And yeah, I've lost USB. I'm not sure if it works still. I think you can program using FTDI. I think I have one of those. This is UART. A bunch of like this stuff. This is a CH341. Bless. One more time. Don't know this one. Oh. Well, can't help. Can't hurt. Let's see if it works or not. I have a feeling it is fried though. More than just the power regulator. Alright, so on this dude I have here, red is the in, black is ground. RxD, I don't need clear to send, I think. CP1102. Well, 1102 is something. CP2102. USB to UART. Your GPI receive should be connected to my TX port. My TX is green, and green goes to the receive, which is GPI. Oh, it says receive, jokes. Okay. Yep. And yellow goes to nothing. White is received, which is the transmit. Like so. They also wanted us to connect ground to, let's say, ground goes to GPIO 0. Where's GPIO 0? GPIO 0 is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let's just double check. Eh. Let's get a bench. I have a feeling it just doesn't work, so no hard feelings if we don't get any signal passing around. Okay, so we're gonna connect our ground to GPI of 0, which is 6780. 1, 2, 2, 2, 2, 2. That. Now something either might catch on fire or it just won't work, and we'll find out. That's my USB port. Okay, let's try and go to a COM port with maybe COM port. There's no secret thought you do not know, no place too dark that your love won't go. I'm not alone, you are on my side. Oh, I got something. And this battleground I will leave behind. I won't have to fight anymore. Can I change? Oh, can I use Tabby? I can. Cool, I haven't fully broken it. Good to know. Now if I unplug that, what's it? Nothing. Never mind, pressing the wrong button. Okay, so yeah, this was my old whatever I put in. Cool, okay, so I think it's just my power supply that I killed. Okay, I might reuse that since we don't really need much USB support. Let's just check I can write into it. So let's create a new GitHub repo. Microsoft Hackathon. PLC Informatics. What did you guys get up to? Server. React, yep, React. Zubat. Hehe, nice name. A-star. Yuck. 2016. Shrug. Okay. Let's. You know, I don't know if I actually need to. Can I just use sort of motor? ESP. Or ESP home, maybe. ESP, listen to button presses. Surely it can do it. I'm just gonna install ESP home. Now the question is, do I want to use ESP home or Tasmoda or Esperna? Why are there so many? Sadness. Nah, I've used ESP easily before. I'm not fast and not. Motor ESP32. Okay, let's put it back. Hope I can power it, otherwise I'll need to get a tap. It would be ideal, but it would work. Now, how do I install you? That. That. What do you mean offline? Yeah, fine, okay. Click, and we'll call you Wi-Fi fan. Vornado 660. Yes, privacy. ESP32. Sure, okay. Install. Plug into this computer. I think I need Chrome. Alright, let's do it again. This time in Chrome. Store, close that. We'll close Tabby as well. Oh, I don't have... That won't work actually. I don't have HTTPS on my dashboard. Mine, we will do it manually. Alright, let's let it come. Oh my goodness, it closed. Building. This is a CH341. And this just plugs in all these stuff. But I have a UART directly. Such a fat chip. Well, it's good to know that I didn't actually fry the board. It still works, it just... the voltage supply is dead, as usual. Whoa. Crypto. Okay, so with our ESP32 anyway. Oh my goodness, I can't resize. Keep forgetting that. Oh, let's do it all again. Let's look at. Goodness, that's fat. I don't want to do that. Yeah, so what did they do? Oh, they just did on the actual buttons rather than the controller. Cat cable. Fair enough. Solder points on the fan's main board. So let's figure out how to hide the bits. Shapes of plastic. Yeah, whatever. How is our thing going? Okay, I need to manually install it. Dashboard install. ESP home. Gotcha. Windows. Click. Need you anymore. Serial port COM4. And this dude. Flash. Do I need a hard reset? I might need a hard reset. That's hard reset. And boot. Yes. Okay, cool. It's not dead yet, and that is good to know. I did not break it yet. Yeah, because I was like playing with the pins in the nice smoke. It's not good. Wait, is this the half-bricked one? Oh yeah, the other one, I think the other one's completely dead. This one is just... I think I threw out the other ones too. Broke. Wait, this is the ESP 32. Do I have 8266? I think I'm out of 8266s. I just bought a bulk batch. Bulk. ESP. What is this? This is a... No, that's a multiplex. I bought a bunch of like pinless, I think. These are all... Oh, these are 826s. Wait, so what else am I going to use my one for? Oh, the Bluetooth thing. Kind of diff. And my face. So I have a H266 here. I don't know if I have enough pins on this H266. 4321. Probably do. Wait, do I just 1, 2, 3, 4, 1, 2, 3, 4. Might use my 8266 mod instead of my Arduino out of the ESP32 because I don't need okay, yeah. Home assistant. Oops. Yeah. I'm gonna edit you and delete or just remove it. Delete. Add that. ESP8266. Configuration created. Okay. Can come back and we'll go install manual download. So all that effort to flash it was kind of in vain because we're not using the ESP32. 32 is for elsewise. What's 90? Sure you are. There you go. Vornado, OTA, API. So let's do I have my Arduino IDE. Can I install Blink? I don't know, I'll just write a note saying this is for my ESP32 is for my USB thingy. My pen worked. Oh, it does. USB thingy. Okay. Unplug. Ground. Unplug voltage plus minus. Oh, I should also write that these 5-volt dead. Bro. Downloads. Let's open our flasher. Is this boy? I'm gonna unplug my programmer, and we're gonna plug in our module. And I figure out how I open it because I don't have my. Where's my scissors? It's the other room. Now I could, if I wanted to. I'm gonna eventually solder the jumper. Maybe I won't. I probably won't. Let's connect my USB micro cable back. refresh the list. Right. And then this. And we wait for it to finish. You can see it flash as it does its bunch of stuff. Cool, alright. I'm gonna close that and just start through tab E. The superior reset. You know, that doesn't feel like that's the right one. 96. Unplug. Plug. Reconnect. Press. What is this? Well, I can't read the logs. Clean MQTT. Not sure what it's doing. Is this 826? Yep, ESP8266. Why do you not have any output for me? To be fair, it's not actually reconnecting, is it? No, it's not. 1152. Let's try 96. Nothing on 96. 9200, no. Too many bits at once. I'm gonna just reflash it, I think. Install it again. Download. 2.7 and flash. Whilst we do that, let's look at BindRanger and let's just look at the thing out of interest, what it does. Leave that there. We will not open any time it loads. And bin file, it's not really a thing. You kind of need to use a elf thingy-majig. Bin walk for Windows? I tried this last time, it didn't work. Saves. Really? Sure. Yeah, I didn't get any function. Okay. Says it's connected. Update available. Okay, so we should be able to edit it. I'm gonna check it here first. Because we have incriminating information. Secrets editor. Date all. What is this button? Bunch of stuff that I don't want it to do. Okay, cool. As I go to my configuration, which is under here. Nope, it's not under here. It's This one. This one. Configuration. I don't know. Whatever. I can basically edit the configs to figure out what the stuff is. Now the thing is, I don't know what they are, so for now, I'm just gonna remove that, and so I can show you guys. This is the interface for the Vornado, and I just need to map out the buttons on the ESP. Okay, so I just need to solder it basically onto our pins. I'm probably not going to do it today just because I need to clean my bench and I don't want to do that right now, so probably call it a night here. I'm going to take a nap. Tomorrow's Tuesday. We'll get this out of the way and then we'll work on my thesis stuff. Yeah. Alright, cool. That was a good waste of 2 hours. I love doing pinouts. Great. You know what? Let's make a quick pinout thing on our GitHub. And we'll just save our diagram. Beautiful diagram. Pin 4 is VCC. Pin 11 is ground. And the device is a whatever it is that. Where'd my Git? Cool, and let's just do a graphical pinout. Cancel. Add file. Uploads. Click. This one. Alright, cool. I have my daily Git commit done. Did I make a commit yesterday? I don't remember. Did I? Did I? Oh, yeah, I did. But is this a thing to delete? I think this is a thing to delete. This is a thing to delete. Delete. I just leaked my GitHub password. My bad. Let's change our password now. That was awkward beyond everything. Yeah, I'm gonna change it later, but now. Alright, I'm gonna disappear. We will continue that tomorrow. Alright, bye.